Have you ever looked up at the night sky and wondered, where did it all come from? The universe, with its billions of galaxies, stars, and planets, is a place of awe-inspiring beauty and mystery. For centuries, we've pondered our place in this vast cosmos, searching for answers to the biggest questions of all. How did the universe begin? And will it ever end? We often imagine the universe starting with a single, explosive event, the Big Bang. It's a powerful image, a sudden burst of energy from a tiny point creating everything we see around us. But what if the Big Bang wasn't the beginning? What if it was just one chapter in a much grander story? What if instead of a straight line from beginning to end, the universe is more like a circle, a never-ending cycle of birth, growth, death, and rebirth? This might sound like something out of science fiction, but there's a growing body of scientific thought that suggests the universe might not be a one-time event. Imagine a universe that never truly dies. It expands for eons, stars ignite and fade, galaxies drift apart, but instead of fading into a cold, empty void, this universe begins to contract. Gravity, the architect of the cosmos, pulls everything back together. This contraction doesn't lead to oblivion, though. Instead, it culminates in an unimaginable event, a point of incredible density and energy. But instead of a final collapse, a spectacular rebound occurs, a big bounce. From the ashes of the old universe, a new one bursts forth, full of potential and possibility. This idea, known as the Big Bounce theory, challenges our perception of time and creation. If the universe goes through cycles of expansion and contraction, then the Big Bang we talk about might just be the most recent one in an endless series. Imagine each big bounce as a cosmic reset. With every cycle, the universe gets a fresh start. New stars are born, new galaxies take shape, and perhaps in some corner of this reborn cosmos, new life emerges. The concept of a cyclical universe is captivating. It paints a picture of a universe that is eternally dynamic, constantly reinventing itself. It offers a sense of continuity, a cosmic dance where endings and beginnings are intertwined. But how could such a cycle even be possible? What forces could drive the universe to contract and rebound in this way? To answer these questions, we need to delve deeper into the heart of the cosmos, where objects of unimaginable power hold sway, black holes. Picture the universe as an endless dance floor. Galaxies twirl and stars shimmer like celestial dancers, moving to a rhythm we're just beginning to understand. For a long time, we thought this dance had a definite beginning, the Big Bang, and would eventually end in a cold, dark silence. But imagine if, instead of a final curtain call, the music changed, the tempo shifted, and the universe itself began to move in reverse. What if instead of fading away, the universe pulled a cosmic U-turn? That's the essence of the Big Bounce theory. Imagine everything we see around us, stars, galaxies, even the space between them, drawing closer and closer together. The universe, once expanding, would begin to contract, shrinking down until it became incredibly hot and dense, almost unimaginably so. But instead of collapsing into oblivion, the universe would experience an incredible rebound, a bounce that would send everything flying outward once more. This bounce, this moment of cosmic renewal, would mark the beginning of a new cycle, a fresh start for the universe. Now, you might be wondering what could possibly drive such a mind-boggling event as a big bounce. Well, let's talk about black holes. We usually think of them as cosmic vacuum cleaners, sucking up everything that gets too close. And while their gravity is undeniably intense, they might also hold the secret to the universe's rebirth. Think of it this way: when a massive star collapses in on itself, it forms a black hole, a region of space-time where gravity is so strong that nothing, not even light, can escape. But what happens to all that matter trapped inside? Some scientists believe that the immense pressure and energy at the heart of a black hole could spark a new Big Bang. Imagine it, a black hole acting as a cosmic seed, planting the seeds for a new universe to sprout within its depths. This new universe, hidden from our view, would expand and evolve in its own separate reality. And here's a truly mind-bending thought: our own universe could have been born from a black hole in a previous universe, a cycle of cosmic creation echoing through eternity. Think about the faint afterglow of the Big Bang, the cosmic microwave background radiation that permeates the universe. It's like a baby picture of the early universe. And some scientists believe that hidden within this afterglow, we might find subtle patterns, whispers of previous universes that existed before ours. Imagine finding evidence of a universe that lived and died before our own, its final moments imprinted on the fabric of our cosmos. It's a mind-blowing concept, but it highlights the beauty of the cyclical universe idea, the possibility that nothing truly ends, it simply transforms. If the universe does go through cycles of death and rebirth, it changes our entire perspective on existence. Time itself becomes a loop, with no true beginning and no true end. Each cycle could be different, with its own unique properties and constants, leading to an unimaginable diversity of universes across the vastness of, well, everything. We've talked about black holes potentially birthing new universes nestled within their depths. But imagine this. What if those new universes, in turn, give rise to even more universes through their own black holes? It's like a cosmic family tree, with our universe as just one branch among countless others. Each black hole, a potential seed for a new universe to blossom, creating a sprawling, interconnected web of universes, each with its own unique story to tell. This idea, known as the black hole universe theory, suggests that the universe isn't just expanding but also multiplying. It's a mind-boggling concept, a departure from the traditional view of a single universe that began with a Big Bang. It challenges us to expand our thinking, to imagine a reality far grander and more complex than we ever thought possible. If the idea of black holes birthing universes intrigues you, then hold on tight because it leads us to an even more profound concept, the multiverse. Imagine a vast tapestry woven from countless threads, each thread representing a different universe with its own unique set of physical laws, its own cosmic recipe. Some universes might be similar to ours, with familiar stars and galaxies, while others could be wildly different, governed by forces we can barely comprehend. Some might even have different dimensions beyond our ability to perceive or imagine. The possibilities are literally endless. The multiverse hypothesis is still a topic of debate among scientists, but it offers an elegant explanation for some of the biggest mysteries in physics. For example, why do the fundamental constants of our universe seem so finely tuned for life to exist? The multiverse offers a possible answer. If there are countless universes, each with its own set of physical laws, then it's not so surprising that we find ourselves in a universe that's just right for us. It's like winning the cosmic lottery, but instead of a single ticket, there are infinite tickets, and someone, somewhere, was bound to get lucky. Our universe, with its familiar stars, galaxies, and planets, might be just one branch on an unimaginably vast cosmic tree. And within each of those other universes, countless stories could be unfolding, stars igniting, galaxies colliding, maybe even life evolving in ways we can't even imagine. The concept of the multiverse is both humbling and exhilarating. It reminds us that we are just a small part of something much grander, a cosmic tapestry woven from the threads of countless universes. And it opens up a universe, or rather, a multiverse, of possibilities, urging us to keep exploring, keep questioning, and keep searching for answers to the biggest questions of all. Let's dive into the brilliant mind of Roger Penrose, a physicist known for his groundbreaking work on black holes and the universe. He has a theory called conformal cyclic cosmology, and it paints a picture of a universe that's always existed, always changing, always renewing itself. Penrose asks us to imagine the universe not as a single event, but as a grand cycle. Imagine the universe expanding and cooling over unimaginable periods. We're talking about trillions upon trillions of years, far longer than the current age of our universe. Over these vast stretches of time, stars exhaust their fuel, galaxies drift apart, and even black holes eventually evaporate, leaving behind a faint whisper of energy. The universe becomes a vast, almost empty expanse filled with fading echoes of its former glory. It's a bit like a deep breath out, a cosmic exhale. Now, here's where Penrose's theory gets really interesting. As the universe empties out and expands, something remarkable happens. The fabric of space-time itself, the very essence of the universe, stretches and smooths out. Imagine a wrinkled cloth slowly being pulled taut. That's kind of like what happens to space-time in Penrose's model. And in this smoothed out, almost pristine state, the universe is primed for a dramatic transformation. You see, according to Penrose, at these incredibly large scales where space and time become almost meaningless, the universe essentially forgets its past. It forgets its size, it forgets its history, it becomes like a blank slate, ready for a new beginning. And that's when the cycle begins anew. From this state of almost pure energy and potential, a new Big Bang erupts, marking the birth of a new cosmic cycle. It's as if the universe takes a deep breath in, a cosmic inhale, and bursts forth with renewed energy. What's even more fascinating is that Penrose believes we might be able to find evidence of these previous cycles. He suggests that faint patterns in the cosmic microwave background radiation, the afterglow of the Big Bang, could hold clues to these past universes. Imagine finding these whispers from a bygone age, subtle imprints of a universe that existed before our own. It would be like finding a message in a bottle, tossed across the ocean of time from a long-lost civilization. Penrose's theory offers a tantalizing glimpse into the universe's grand, cyclical nature, a cosmic dance of expansion, cooling, and rebirth that has potentially been going on for an eternity. We've explored some mind-bending ideas about the universe being cyclical, with big bounces and black holes sparking new beginnings. But what if those new beginnings weren't just happening in sequence, but happening all at once, across a landscape so vast it makes our concept of universe seem tiny? That's where the idea of the multiverse comes in. Imagine not just one universe, but an infinite number of them, all existing simultaneously, each with its own unique set of physical laws, its own cosmic fingerprint. It's a concept that stretches the limits of our imagination, but it's one that many physicists believe could be true. Think about it. Our universe is unimaginably vast, but what if it's just one bubble in an even vaster cosmic foam, a sea of universes stretching out infinitely in all directions? Section 2. A cosmic tapestry. Each thread a universe. Imagine each universe as a unique thread in a cosmic tapestry. Some threads might be similar in color and texture, representing universes that resemble our own, with familiar stars, galaxies, and maybe even life. But other threads could be wildly different. Bright, vibrant threads representing universes with different dimensions, strange forces, and laws of physics that would seem like magic to us. There could be universes where gravity works differently, where time flows backward, or where the very fabric of reality is constantly shifting. The possibilities are literally endless, limited only by our imagination. And within this vast tapestry of universes, every possible outcome, every alternate history, every path not taken could be playing out somewhere. Section 3. The Goldilocks Enigma. Why our universe is just right. Now, you might be wondering, if there are infinite universes, why do we find ourselves in this particular one with its specific set of physical laws that just happen to allow for stars, planets, and life as we know it? It's like looking at a lottery ticket and realizing you have the winning numbers. The odds seem astronomically small. This is sometimes called the fine-tuning problem or the Goldilocks enigma, because our universe seems just right for life. The multiverse offers a potential explanation. If there are infinite universes, each with its own randomly determined set of physical laws, then it's statistically inevitable that some universes will be life-permitting, while others will be sterile, chaotic, or simply too strange for life as we know it to emerge. Section 4. A universe or multiverse of possibilities. We just happen to find ourselves in one of the lucky ones, a universe where the fundamental constants of nature, the strengths of forces, and the masses of particles are all in that sweet spot that allows for stars to ignite, planets to form, and life to arise. It's a humbling thought, but also an exhilarating one. The multiverse, if it exists, is a vast canvas of possibilities, a cosmic playground where the laws of physics themselves can vary from one universe to the next. And while we may never be able to visit these other universes or even prove their existence definitively, the very idea of them expands our horizons, pushes the boundaries of our imagination, and reminds us that the universe, or rather the multiverse, is far stranger, grander, and more full of wonder than we could have ever imagined. Cosmic collisions, a new kind of bang. We've journeyed through some incredible ideas about how our universe might be part of a much grander cycle, with big bounces, black holes birthing new universes, and even the mind-boggling concept of the multiverse. But hold on tight, because we're about to explore a theory that takes us even deeper into the realm of the unknown. Imagine, if you will, that our universe isn't just expanding in a vast emptiness, but that it's actually embedded in a higher dimensional space, a realm beyond our ability to directly perceive. And within this higher dimensional space, there are other universes, not as separate bubbles, but as massive objects called brains. Think of brains like giant sheets, but instead of being flat, they can be curved and folded, existing in dimensions we can only imagine. And sometimes these brains collide. These aren't your everyday fender benders, mind you. We're talking about cosmic events of unimaginable power, collisions that release enough energy to create a universe. Brains, the fabric of reality, revisited. This is the essence of the ekpyrotic universe model. It suggests that our universe was born not from a singularity, as in the traditional Big Bang theory, but from a titanic collision between two of these brains. Picture these brains hurtling towards each other across the vastness of this higher dimensional space. As they draw closer, energy builds up between them, like a cosmic spring being compressed. And then, bam! The brains collide, releasing a mind-boggling amount of energy in an instant. This energy, according to the ekpyrotic model, isn't just spewed out randomly. It's channeled into the creation of a new universe, our universe. It's as if the collision of these brains provides the spark, the raw materials, and the blueprint for an entirely new cosmos to come into being. The eternal dance, a universe without end. But here's the really intriguing part. The ekpyrotic universe model doesn't just stop with one collision. It suggests that these brain collisions could happen over and over again, perhaps even cyclically. Imagine the brains bouncing back after a collision, only to be drawn back together by some unseen force destined to collide again, perhaps billions or trillions of years later. Each collision would mark the birth of a new universe, a fresh start to the cosmic dance. It's a captivating concept, the idea of these massive, unseen brains orchestrating the birth and death of universes, playing out a cosmic ballet across unimaginable stretches of time and dimensions. And it raises the question, if our universe was born from a brain collision, could we find evidence of it hidden somewhere in the fabric of space-time? Could there be echoes of that primordial crash, subtle clues pointing to a time before time as we know it? As we explore these mind-bending theories, it's important to remember that we're still searching for answers, piecing together the universe's story one discovery at a time. We don't have all the answers yet, and that's okay. That's what makes science so exciting. The beauty of science lies in its willingness to embrace the unknown, to challenge assumptions, and to constantly seek new knowledge. And as we delve deeper into the mysteries of the cosmos, we discover a universe that is far stranger, grander, and more awe-inspiring than we could have ever imagined. The idea of a cyclical universe, whether through big bounces, black hole universes, a multiverse, or brain collisions, challenges us to rethink our place in the grand scheme of things. If the universe is not a one-time event, but part of an eternal cycle, then we are part of something truly magnificent, a cosmic dance that has been going on for eons and will continue long after we're gone. So the next time you look up at the night sky, let your imagination soar. Let yourself be filled with wonder and curiosity. Because out there, among the stars and galaxies, lies a universe full of endless possibilities waiting to be explored. We've journeyed through a cosmos of mind-bending possibilities. We've explored theories suggesting our universe might not be a singular event, but part of an endless cycle of death and rebirth. From big bounces to black hole universes, from the multiverse to colliding brains, these concepts challenge us to expand our perception of reality. Think about it. For centuries, we clung to the idea of a universe with a defined beginning and end. But what if the universe has always existed and always will, simply transforming from one state to another? What if the end of one cycle is merely the beginning of the next, a cosmic dance with no true beginning or end? This shift in perspective is profound. It replaces the idea of a finite universe with the awe-inspiring concept of an eternal cosmos, constantly changing, evolving, and renewing itself. It's a humbling yet exhilarating thought, a reminder that we are part of something far grander than we can fully grasp. Imagine the universe as a symphony, a grand composition of energy, matter, and time. The Big Bang, if it was indeed just one of many, might be seen as the crescendo of the previous movement, a burst of energy that set the stage for the current chapter of the universe's story. As our universe expands and cools, stars are born, live out their lives, and die, scattering the seeds for new stars and planets. Galaxies collide and merge, reshaping the cosmic landscape. And perhaps in some distant future, the expansion will slow, stop, and reverse, leading to a big crunch, a cosmic collapse that sets the stage for the next big bounce. This cyclical view of the universe reveals a beautiful interconnectedness, a cosmic dance where every ending is a new beginning. It's a reminder that nothing is truly lost, only transformed, recycled, and reborn in the grand cosmic scheme of things. So where do we fit into this grand cosmic dance? We are, in a very real sense, children of the cosmos, born from the ashes of stars that lived and died long ago. The atoms in our bodies were forged in the hearts of stars. The elements that make up our planet, our bodies, even our thoughts, all originated in the fiery crucibles of stellar evolution. Our lives, though fleeting on cosmic timescales, are nonetheless a part of this grand, eternal cycle. We are participants in the universe's story, contributing to its evolution, however small our part may seem. The knowledge that we are part of something so much bigger than ourselves can be both humbling and empowering. It reminds us that we are connected to everything in the universe, from the smallest subatomic particle to the most distant galaxy. And it inspires us to live our lives with a sense of wonder, curiosity, and a deep appreciation for the beauty and mystery of the cosmos. As we continue to explore the universe, to unravel its secrets and unlock its mysteries, let us remember that we are not merely observers but active participants in a cosmic dance that has been going on for eons and will continue long after we are gone. The universe is a never-ending story, and we are fortunate to be a part of it, even for a little while.